Hello students, well, we are doing exercise 21C, proof trigonometrical identities, isn't it? So in our previous video we have completed question number 1 and today we'll start from question number 2 onward. Okay, so let's begin. So this is question number 2. Express each of the following in terms of angles between 0 to 45 degree. So we are given these 3 questions and the angles here you can see every angle is more than 45 degrees, isn't it? Every angle here is more than 45 degree. Here you can see 59 degree, here 63 degree, here 68, 72, 74 and 67. So we are asked to convert these angles in between 0 to 45 degree, not more than 45 degree and not less than 0 degree, isn't it? So let's do this. Very easy sum, isn't it? So we'll start from question number 1 of 2. Okay, we have sine 59 degree plus tan 63 degree. This can be written as sine 59 means 90 minus, okay, 90 minus, so 10 minus something is 9, 10 minus 1 is 9, isn't it? Now this becomes 8, 8 minus something is 5, 8 minus 3 is 5. Are you getting me? 90 minus 31 is 59, 90 minus 31, so 10 minus 1 is 9 and this becomes 8, 8 minus 3 is 5, so 90 minus 31 gives us 59, isn't it? So instead of this 59 degree I can write 90 minus 31, so plus this is tan 63 degree, tan 63 degree, so this can be written as tan 90 minus something is 63, isn't it? So what number should come here? So this is 10, 0 is 10, 10 minus 7 gives us 3, so this becomes 8, 8 minus 2 is 6, isn't it? 8 minus 2 is 6, so 90 minus 27 gives us 63. Are you getting me? 90 minus 27 gives us 63. So we have the formula sin 90 minus theta, cos 90 minus theta, sec 90 minus theta, tan 90 minus theta, cot 90 minus theta, cosec 90 minus theta, isn't it? So let's check out this. Sin 90 minus theta, okay, sin 90 minus theta, theta is 31 out here. Sin 90 minus theta is cos theta, isn't it? Theta is 31. So here this plus sign comes. Tan 90 minus theta, theta is 27 here, isn't it? So tan 90 minus theta is cot theta, cot 27. So now you can see both the angles are less than 45 degree and more than 0 degree, 31 and 27. So this is the answer for question number 1. Okay, very simple, isn't it? So let's do question number 2. Cosec 68. Cosec 68 can be written as cosec 90 minus something gives us 68, isn't it? Cosec 90 minus something gives us 68. So 10 minus 2 gives us 8 and this becomes 8. 8 minus 2 gives us 6. So this is 22 plus cot 72. We write cot here, cot, and 72 means 90 minus something should give 72. So 10 minus 2, 10 minus 8, 10 minus 8, 10 minus 8 gives us 2. So this becomes 8. 8 minus something should be 7. 8 minus 1 should be 7. Are you getting me? 90 minus 22 is 68 and 90 minus 18 is 72. Okay. Now we have cosec 90 minus theta. Cosec 90 minus theta is sec theta, isn't it? Sec theta, theta is 22 plus cot 90 minus theta, theta is 18 out here. So cot 90 minus theta is tan theta, tan 18 degree. Now you can see both the angles 22 degree and 18 degree are in between 0 and 45 degree, isn't it? So this is the answer for question number 2. Okay, so please take the screenshot. I'll do question number 3 straight away. So in question number 3 we have cos 74. Let me copy this question here. Okay, cos 74 degree plus sec 67 degree, isn't it? This is question number 3. So this can be written as cos 74 means 90 minus something, and 10 minus which number gives us 4? 10 minus 6 gives us 4. So this becomes 8. 8 minus something is 7. 8 minus 1, isn't it? 8 minus 1 is 7. Plus sec 67. That means sec 90 minus, so 10 minus 3 is 7. And this becomes 8. 8 minus 2 is 6, isn't it? So 90 minus 16 is 74 and 90 minus 23 is 67. Okay, so we have now cos 90 minus theta, that is sec theta, sorry sin theta, isn't it? Cos 90 minus theta is sin theta, plus sec 90 minus theta is cosec theta. Cosec theta, theta is 23 degree. Okay, now here you can see both the angles are in between 0 degree and 45 degree, isn't it? So this is the answer for question number 3. Okay, now let us do question number 3. This is question number 2. Okay, question number 3 of 2. Now we'll move on to question number 3. Okay, now let us do question number 1 of 3. Okay, we are asked to prove this equals to sec a into cosec a. Sin a upon sin 90 minus a plus cos a upon cos 90 minus a equals to sec a into cosec a. So we are asked to prove this. Let's copy left hand side. LHS equals to, we have sin a upon sin 90 minus a plus cos a upon cos 90 minus a. This is what we have in the left hand side, isn't it? So we copy the numerator as it is. Okay, sin a, and in the denominator we have sin 90 minus a. Sin 90 minus a means sin 90 minus theta. Sin 90 minus theta is cos theta. So cos and theta is a, cos a. So in the numerator we have cos a, and in the denominator we have cos 90 minus a, that is sin a, isn't it? Cos 90 minus a is sin a. So let's take the LCM of the denominator, cos a and sin a. The LCM will be cos a into sin a. Cos a into sin a, isn't it? So now cos a into sin a gives us this number, cos a sin a. So sin a into sin a, sin square a, plus sin a into cos a gives us this number. So cos a into cos a is cos square a, isn't it? So in the numerator we have sin square a plus cos square a, isn't it? That means sin square theta plus cos square theta is 1 upon cos a upon sin a. Cos a upon, sorry, cos a into sin a. Cos a into sin a, isn't it? So this cos a when taken to the numerator becomes sec a. Okay, because cos a and sec a are reciprocal of each other. So cos a when taken to the numerator becomes sec a, into this sin a when taken to the numerator becomes cosec a. Okay, cosec a, because sec a equals to 1 upon cos a and sin a equals to, this is a, okay, 1 upon cosec a. So sec a and cosec a are reciprocal of each other, and sin a and cosec a are reciprocal of each other. So if you take cos a to the numerator, it becomes sec a. If you take sin a to the numerator, it becomes cosec a. So this is what we have in the right hand side, hence proved, equals to RHS. Okay, now let us do question number 2 of 3. We are asked to prove this whole thing equals to 0, isn't it? So let us not copy left hand side as usual, because this is a too long question, isn't it? It takes a lot of time. But make sure you copy left hand side in the examination before proceeding to solve any question. Okay, it's a good habit. So let's do this. without copying left hand side. We'll proceed on straight away. Okay, LHS equals to we copy the sine A cos A as it is, sine A into cos A. Okay, sine A into cos A minus this sine A. Now cos 90 minus A, cos 90 minus A is sine A, isn't it? Sine A, and this is cos A, and here we have sec 90 minus A. Sec 90 minus A is cosec A, cosec A, isn't it? So minus this is cos A. Here we have sine 90 minus A, that is sine 90 minus A is cos A. So this is sine A, and in the denominator we have cos 90 minus A, that is sec A, isn't it? So we are asked to prove this equals to 0. So this is sine A cos A, sine A into cos A. Okay, now this sine A into sine A is sine square A, isn't it? Sine A into sine A is sine square A. Now if you take this cosec A to the numerator, this cosec A also becomes sine A. Are you getting me? Yes. If you take this cosec A to the numerator, this cosec A also becomes sine A, because sine A and cosec A are reciprocal of each other. So this cosec A goes to the numerator and becomes sine A, and that sine A into this 2 sine A becomes sine cube A, isn't it? Sine cube A, because we have sine square A here. Sine A into sine A is sine square A, and this cosec A also goes to the numerator and becomes sine A. So that sine A into sine square A is sine cube A. Okay, so this is cos A minus, here the same thing, this sec A goes to the numerator and becomes cos A, and that cos A, this cos A, and this cos A, cos A into cos A into cos A becomes cos cube A dot sine A. Okay, dot means into. So you can see the common sine A cos A, isn't it? Sine A cos A, sine A cos A, sine A cos A. So let us take the common sine A cos A. Sine A cos A common out, and within the bracket remains, here we had sine A cos A. Now this sine A cos A is taken out, so 1 remains within the bracket, minus this minus sign comes here. We took out sine A, isn't it? But we had sine cube A here, so sine A is taken out, means sine square A is still remaining inside the bracket, isn't it? Sine square A. Okay, sorry, sine square A, sine square A. We have sine cube A here. 1 sine A is taken out, so sine square A remains within the bracket. Now this cos A is taken out, so we don't need to write this cos A. Minus comes here, and from here the sine A is taken out, so we don't need to write sine A here. From this cos cube A, cos A is taken here, so cos square A remains within the bracket. Cos square A remains within the bracket. Okay, now this is sine A into cos A. Let's open curly bracket. This is 1 minus, so let us take minus sign common from this. Minus sign is taken common, so minus sine square A becomes plus sine square A, and minus cos square A becomes plus cos square A. So when minus sign is taken common, the numbers which are negative becomes positive, and the numbers which are positive becomes negative. Okay, let's check out. Minus into plus is minus sine square A, and minus into plus is minus cos square A. So this is sine A cos A, sine A into cos A. Here we have 1 minus, this one is this one, minus minus, sine square A plus cos square A is 1, isn't it? So sine A into cos A, this bracket means into, isn't it? Bracket means into, so 1 minus 1 is 0. So sine A cos A into 0 gives us 0. Sine A cos A into 0 is, if you multiply any number with 0, the number becomes 0, isn't it? So this is RHS, right hand side. Okay, we have 0 in the right hand side, isn't it? Hence proved. Now let us move on to the next question, question number 3. Okay, now let us do question number 1 of 4. Okay, for triangle ABC, so that sine A plus B whole upon 2 equals to cos C upon 2. So we are asked to prove this sine A plus B whole upon 2 equals to cos C by 2 for triangle ABC. So let's see. So this is a right angle triangle. This is A, this is B and C. The triangle is right angled at B. Okay, so this is angle A, this is angle B, so this is angle C, isn't it? So we need A plus B. You know that for any triangle, sum of all the angles of a triangle is equal to 180 degree, isn't it? That means angle A plus angle B plus angle C, okay, this angle A plus angle B plus angle C equals to 180 degree. We know this very well. So we need A plus B, isn't it? So let us keep this A plus B in the left hand side. A plus B equals to, this 180 is already in the right hand side, so let us take this plus C to the right hand side. It becomes minus C, isn't it? So we know that A plus B equals to 180 minus C. We are going to use this equation. Okay, now in the left hand side we have LHS equals to sine A plus B upon 2, isn't it? Sine A plus B upon 2. So this means sine A plus B means 180 minus C. A plus B means 180 minus C. How do we get this? Because sum of all the angles of a triangle gives us 180 degree for any triangle. Okay, if you add all the angles of a triangle, means a triangle has 3 angles, isn't it? If you add all the 3 angles of a triangle, you get 180 degrees. So angle A plus angle B plus angle C is 180. So A plus B we keep in the left hand side, and let us take this plus C to the right hand side. It becomes minus C. That means A plus B equals to 180 minus C. So now A plus B, instead of this A plus B, I can write 180 minus C, because A plus B is 180 minus C, isn't it? So instead of this A plus B, I can write 180 minus C, okay, whole upon 2. Are you getting me? I hope so. Now let us move further. We have sine. So let us divide this 180 minus C individually by 2. Okay, so this means 180 upon 2 minus C upon 2, isn't it? So 180 minus C whole upon 2 means 180 by 2 minus C upon 2. 2 when taken LCM gives us this number, isn't it? So this means sine 2 1s are 2, 2 9s are 18, 2 0s is 0. This means sine 90 minus C upon 2. So sine 90 minus theta. Theta is C by 2 here, okay? Theta is C by 2. Sine 90 minus theta is cos theta, isn't it? Cos theta, theta is C by 2. So we have cos C by 2 in the right hand side, hence proved, equals to RHS. Excuse me. So we were asked to prove sine A plus B whole upon 2 equals to cos C by 2. So we used sine A plus B whole upon 2, and we found that this equals to cos C by 2, isn't it? Now let us do question number 2 of 4. Okay, for triangle ABC, so that tan B plus C upon 2 equals to cot A by 2. So we are asked to prove this equals to this, isn't it? For triangle ABC. So let's draw triangle. This is triangle, right angle triangle, right angled at B. Okay, so this is A, this is B, and this is C. So you can see this is angle A, this is angle B, and this is angle C, isn't it? As I told you in the previous video, question number 1, if you add all the three angles of a triangle, you get 180 degrees, isn't it? So let's do the same thing here. Angle A plus angle B plus angle C. If you add all the three angles of a triangle, you get how much? 180 degree. So now we need B plus C, isn't it, in the left hand side? So let us keep this B plus C here and take this plus A to the right hand side, okay? Or B plus C equals to 180 plus A when goes to the right hand side becomes minus A, isn't it? So we are going to use this, okay? Now let's use left hand side. LHS equals to tan B plus C upon 2, tan B plus C upon 2. This means tan B plus C means 180 minus A. Instead of this B plus C, I can write 180 minus A, isn't it, whole upon 2. So tan, now 180 minus A can be written as 180 upon 2 minus A upon 2, isn't it? You can divide this numerator by 2 individually, okay? So this can be written as 180 upon 2 minus A by 2. 2 when taken LCM gives us this number, 180 minus A upon 2, isn't it? So tan 2 1s are 2, 2 9s are 18, 2 0 0. So 90, we have 90 here, minus A by 2. So tan 90 minus theta is cot theta, isn't it? So cot theta is what? A by 2. Okay, so this is what we have in the right hand side, RHS. Hence proved. Okay, now let us do question number 1 of 5. Okay, evaluate. Evaluate means find the value of. Okay, we are asked to find the value of this given expression. So let's do this. This means 3. Okay, this 3 is here. Sine 72, I copy as it is. Okay, sine 72 degree. Sine 72 degree. Now cos 18 means cos 90 minus 72. 90 minus 72. This cos is this cos. 90 minus 72 gives us 18, isn't it? So 10 minus 2 is 8. This becomes 8. 8 minus 7 is 1. Okay. So minus we have here. So let's put this minus sign. Sec 32 I copy as it is. Sec 32 degree upon cosec 58 means cosec 58 means 90 minus 32, isn't it? So 10 minus 2 is 8 and this becomes 8. 8 minus 3 is 5. So 90 minus 32 means 58. So here we have 3 into sine 72 degree in the numerator, and in the denominator we have cos 90 minus theta, isn't it? Cos 90 minus theta is sine theta. So sine theta is 72 minus this minus sign comes here. Sec 32 we copy as it is. Sec 32 degree. In the denominator we have cosec 90 minus theta, isn't it? Cosec 90 minus theta is sec theta. So sec theta is 32, isn't it? So this sine 72 and sine 72 can be cancelled. Similarly, sec 32 and sec 32 can be cancelled. So we have 1 here and we have 1 here. So 3 1s are 3 minus this 1. So 3 minus 1 is 2, isn't it? So we were asked to find the value of this expression and the value is 2. Okay, this is the answer. So let us move to question number 2 of 5. Okay, now let us do question number 2 of 5. Evaluate. We are asked to find the value of this expression. Okay, and this question has been asked in the year 2013, ICSE examination 2013. Okay, so let's do this. Very simple question. This 3 comes here as it is. We copy cos 80 as it is. Okay, cos 80 degree. Now this cosec 10 degree can be written as cosec 90 minus 80. 90 minus 80 gives us 10, isn't it? 90 minus 80 gives us 10. So this cosec is this cosec. 90 minus 80 is 10. Instead of 10, I am writing 90 minus 80. Okay. So plus 2 sine 59, I copy as it is, sine 59 degree. So instead of this sec 31, I write sec 90 minus 59. 90 minus 59 is 31. 10 minus 9 is 1, and this becomes 8. 8 minus 5 is 3. So this sec is this sec. Instead of this 31, I can write 90 minus 51, isn't it? 90 minus 51 gives us 31. Okay. So this is 3 cos 80 degree into cosec 90 minus theta is sec theta, isn't it? Cosec 90 minus theta is sec theta. So sec theta is 80 degree. Cosec 90 minus theta is sec theta. Theta is 80. Are you getting me? Yes. Cosec 90 minus theta is sec theta. Plus 2, we copy as it is, sine 59 degree. So this is sec 90 minus theta, isn't it? Sec 90 minus theta is cosec theta. So cosec theta means 59. So we have 3. Here you just see the angle, okay? If the angle are same, then only we can apply the formula. So cos 80 into sec 80 means cos theta into sec theta. Angles are same. Cos theta into sec theta gives us 1. You know that cos theta equals to 1 upon sec theta, isn't it? So sec theta and cos theta can be cross multiplied. So let's bring this sec theta to the numerator in the left hand side. Cos theta into sec theta equals to 1. So cos theta into sec theta equals to 1. Here you can see the angles are theta in both the cases. If one angle is theta and another angle is something else, then this multiplication will not give 1. Okay, angles should be same. So this should be kept in mind. So here also we can see the angle same, 80 and 80. This means cos theta into sec theta is 1. So this is 1 plus similar principle applies here also. Sin theta into cosec theta. Sin theta equals to 1 upon cosec theta, isn't it? So this cosec theta can be brought to the left hand side by cross multiplication. Sin theta into cosec theta gives us 1. This means when you multiply sin theta into cosec theta, we get 1. But we must keep in mind that the angles should be same, theta and theta. Okay. If here we have one angle and here we have another angle, the product will not give 1. Okay. So here also you can see the angles are similar, 59 and 59, not similar, same, 59 and 59. Okay. So sin theta into cosec theta is 1. So this means 3 into 1 is 3 plus 2 into 1 is 2. So 3 plus 2 is 5, isn't it? This is the answer for this expression. Okay. So we are asked to find the value of this expression and the answer is 5. Let's do question number 3 of 5. Evaluate the value of this expression, isn't it? So sin 80 upon cos 10, isn't it? So sin 80 we copy as it is. Now instead of this cos 10, cos 90 minus 80 can be written, isn't it? Instead of this 10, I can write 90 minus 80. So 90 minus 80 gives us 10 plus sin 59 I copy as it is, sin 59 sec. So instead of this 31, I can write 90 minus 59. So 10 minus 9 is 1 and this becomes 8. 8 minus 5 is 3. So 90 minus 59 gives us 31. Okay. So sin 80 is in the numerator. In the denominator we have cos 90 minus theta. Theta is 80 degrees, isn't it? So cos 90 minus theta is sin theta. So sin 80 plus this is sin 59 into this is 9. Okay. Sin 59 into sec 90 minus theta. Sec 90 minus theta. Theta is 59. This is cosec theta, isn't it? So this sine 80 can be cancelled, and here we have 1 in the numerator. So sine 59, let's write this one first. This one plus sine 59 into cosec 59. Angles are same, so sine theta into cosec theta gives us 1, isn't it? So 1 plus 1 equals to 2. The value of this expression is 2. Okay, very simple, isn't it? Okay, now let us do question number 4 of 5. Okay, question number 4 of 5. So we are asked to find the value of this expression, isn't it? So we have tan 55 minus a minus cot 35 plus a. So let's write this. This can be written as tan 55. Okay, 55 means 90 minus 35, isn't it? 90 minus 35 gives us 55. 10 minus 5 is 5, and this becomes 8. 8 minus 3 is 5 minus a. Okay, we copy this as it is, minus cot 35 plus a. Now this is tan 90. Let us take the minus sign common, minus, so this becomes 35 plus a, isn't it? Let us put this curly bracket here. So minus into plus 35 is minus 35, minus into plus a is minus a. Okay, so minus cot 35 plus a. Are you getting me? This 55 is written as 90 minus 35, because if you subtract 35 from 90 you get 55. Now what I do is I take minus sign common. Okay, this 90 is here. So when I take minus sign common, the numbers which are negative becomes positive, isn't it? Because if I multiply this with the minus sign, I get this. Minus into plus 35 is minus 35, and minus into plus a is minus a. Okay, so tan 90 minus theta. Theta is 35 plus a, isn't it? Tan 90 minus theta is cot theta. Cot theta, what is theta? 35 plus a, isn't it? Theta is 35 plus a. Tan 90 minus a is cot theta, minus, this minus comes here, cot theta. Theta is 35 plus a. So cot 35a, cot 35a, and this number is negative and this number is positive. Same number, opposite sign. So this minus this gives us 0. So the answer for this expression is 0. Okay, so let's begin. Let's do question number 5. Do question number 5 of 5. Okay, evaluate. We are asked to find the value of this expression, isn't it? So let's do this. So here we have cosec 65, isn't it? 65 means 90 minus 25. 90 minus 25 gives us 65, and we have plus a here. This plus a comes here. 90 minus 25 is 65. Okay, 10 minus 5 is 5, and this becomes 8. 8 minus 2 is 6. This minus sec 25 minus a, we copy as it is. So this is cosec. Now 90, let me put curly bracket. Okay, 90 minus 25 minus a whole. Now let's check. Minus into plus 25, minus into plus, just before 25, within the bracket before 25 we have plus sign, isn't it? So minus into plus 25, minus 25, minus into minus is plus, minus into minus is plus, and this is a. Okay, so what I wanted to do is I wanted to make similar to this 25 minus a. Okay, 90 minus theta minus sec 25 minus a, isn't it? So here we have cosec 90 minus theta. Did you get this? How did this number come? This 90 minus 25 is 65. Instead of the 65, I wrote 90 minus 25. Now what I did is I changed the sign of a to minus and put the bracket. This means minus into plus is minus 25 and minus into minus a is plus a. Nothing is changed, okay? So cosec 90 minus theta, theta is this, isn't it? Cosec 90 minus theta means sec theta. Sec theta, theta is 25 minus a, 25 minus a, okay? Cosec 90 minus theta, that means sec theta, theta is 25 minus a, and minus sec 25 minus a. So both the numbers are same and the signs are opposite. One has minus sign and another has plus sign. So sec this and sec this becomes 0. Okay, question number 6 now. Question number 6 of 5. So we are asked to find the value of this expression, isn't it? So we have 2 tan 57. I copy as it is, tan 57 degree. Okay, in the denominator I have cot 33 degree, isn't it? So cot 33 means 90 minus 57. 90 minus 57 gives us 33. Okay, 10 minus 7 is 3. This becomes 8. 8 minus 5 is 3. Minus cot 70, I write as it is, cot 70 degree, upon tan 20 means tan 90 minus 70. 90 minus 70 gives us 20. 0 minus 0 is 0. 9 minus 7 is 2, isn't it? So minus, here we have root 2 into cos 45 means 1 upon root 2, isn't it? So I have taught you to find the values of different angles of sine, cos, tan, cot, sec and cosec, isn't it, in the first video. If you don't know that, if you have not seen that video, please check out that video. Okay, so the value of cos 45 is 1 upon root 2. So you can cancel this root 2 and root 2. Now we have 2 tan 57 degree, and in the denominator we have cot 90 minus theta. Cot 90 minus theta is tan theta, tan 57 degree, minus cot 70, I write as it is, cot 70 degree. So tan 90 minus theta is cot theta, cot 70 degree, minus, this minus comes here and this is 1. These two are cancelled, isn't it? So you can cancel this and this as well, and this also. So this is 2, 2 1 ja, here we have 1, 2 1 ja 2, minus, here we have 1, 1 and minus 1, minus 1. So 2 minus 1 minus 2. So 2 minus 2 is 0, isn't it? So the answer for this question is 0. Okay, so let's move on to the next question. Okay, let's do question number 7 of 5. So we are asked to find the value of this expression, isn't it? So let us copy the numerator as it is, cot square 41 degree, cot square 41 degree. In the denominator we have tan square 49, isn't it? 49 can be written as 90 minus 41. So this is 41, okay? 90 minus 41. 10 minus 1 is 9. This becomes 8. 8 minus 4 is 4. 90 minus 41 is 49. So this is minus, and here we have 2. Sine square 75. Sine square 75 whole upon cos square 15. Cos square 15 can be written as 90 minus 75. 10 minus 5 is 5. So this becomes 8. 8 minus 7 is 1. So cot square 41, we copy this as it is, and in the denominator we have tan 90 minus theta. 90 minus theta, theta is 41, isn't it? So tan 90 minus theta is cot theta. So cot, here we have square, so let's put square as well, 41. So no need to put bracket, isn't it? 41 minus, here we have 2 into sine square 75. Sine square 75. Similarly, cos 90 minus theta is sine theta. So sine, so we have square here, let's put square. Theta is 75. So cot square 41 can be cancelled. We have 1 here. Sine square 75 and sine square 75 cancelled, 1 here. So 1 minus, this minus comes here, minus 2 ones are 2. So plus 1 minus 2 is minus 1, isn't it? 2 minus 1 is 1, the sign of greater number comes here. So this is the answer. Okay, let us do question number 8. Okay, so we have cos 70 degree in the numerator. Let us copy this as it is, cos 70 degree. In the denominator we have sine 20 degree. This means sine 90 minus 70. 90 minus 70 gives us 20, isn't it? 0 minus 0 is 0, 9 minus 7 is 2. So this is plus. Cos 59 degree we copy as it is, cos 59 degree upon sine 31, means sine 31 means 90 minus 59. 10 minus 9 is 1 and this becomes 8. 8 minus 5 is 3. Okay, so minus 8 sine 30 degree means sine 30 means 1 upon 2. 1 upon 2, isn't it? Sine 30, the value of sine 30 degree is 1 upon 2. And we have sine square, means we must square this. Okay, so cos 70 we copy as it is, cos 70 degree. Now here we have sine 90 minus theta. Sine 90 minus theta is cos theta, that is cos 70, plus cos 59 we copy as it is, cos 59 degree. In the denominator we have sine 90 minus theta. Sine 90 minus theta, theta is 59, so that is cos 59, isn't it? Minus, this is 8 into 1 squared means 1, 2 squared means 4. So this cos 70 and cos 70 cancels out. We have 1 in the numerator. Cos 59 cancels out, 1 in the numerator. So 1 plus 1 is 2, isn't it? Plus 1 plus 1, 2, minus 4 1s are 4, 4 2s are 8, 2. 4 1s are 4, 4 2s are 8, minus 2, minus 2. So 2 minus 2 is 0. So the answer for this expression is 0. Okay, so let's do the next question. Question number 8. 9 of 5. So we have 14 sine 30 degree plus 6 cos 60 minus 5 tan 45 degree, and we are asked to find the value of this expression. Okay, so let's do this. 14, we have 14 sine 30 means 1 upon 2. Okay, plus this is 6 into cos 60 means 1 upon 2 minus 5 tan 45 means 1. Okay, tan 45 means 1. So we should know the value of this. I have already made a video for this, how to draw and find the trigonometrical values for different angles. Okay, you can check out the first video of exercise 21C. So sine 30 degree means 1 upon 2, cos 60 degree means 1 upon 2, and tan 45 degree means 1. So now 2 1s are 2, 2 7s are 14, 2 1s are 2, 2 3s are 6. So 7 into 1, there is only 1 in the denominator. Every number has 1 in the denominator, so we need not write that. So 7 1s are 7, plus we have 3 here, 3 1s are 3, minus 5 1s are 5. So 7 plus 3 is 10, isn't it? 7 plus 3 is 10, 10 minus 5 is 5. This is the answer for question number 9 of 5. Okay, so this was for today. I will continue this chapter in the next video. Thank you so much.